Today's learning target, I can identify a function as discrete or continuous. So we have two new vocabulary words. Those words are discrete, and the other word is continuous. Can you draw a function without picking up your pencil? Yes. If the answer is yes, then the function is continuous. A continuous function does not have any breaks or holes. If the answer is no, then it is discontinuous. Because a discontinuous function does have breaks and holes. Which one can be drawn without picking up the pencil? The one on the left is continuous. It is a smooth curve. The one on the right is discontinuous. It starts on the left, increasing, and then it stops, and it jumps. So there's a break here, and it goes along smoothly this way, but there is still this break right here, big break, big break. And the break means that it is not continuous, it is discontinuous. Okay. This next one actually asks you, is it discrete or continuous? Discrete we haven't actually mentioned yet, but discrete means that it is individual points. Individual points. This particular graph is discrete. It is individual points. There's a point, there's a point, and a point, and a point, and a point. Discrete graphs are graphs of individual points, as if you were counting. Oops, I spelled counting wrong. Sorry. It is not continuous. Discrete is not continuous. The next question up there says, is it a function? If we check using the vertical line test, the vertical line test says anywhere we put a vertical line, if it only passes once through the function, then it is a function. So we have a point here. If we put a vertical line, it only goes through that point one time. Let's try the next one. Only goes through a point one time. Let's switch colors and try again. Okay, let's try this one. Again, no matter where I draw that vertical line, I'm only crossing one point on my graph. So yes, it is a function. Discrete or continuous? We can draw it without picking up our pencil. Therefore, it is continuous. It is not unconnected individual points. Is it a function? Does it pass our vertical line test? Let's try that. I need to get a vertical line. So, I have my vertical line. And let's see what happens when I put my vertical line here. If I put my vertical line there, then I only pass the graph one time. But if I put my vertical line passes through the graph more than one time. And there are many places where it passes through the graph more than one time. So is this a function? No, it is not. It does not pass the vertical line test. Discrete or continuous, or is it neither? Is it discrete? No, it is not discrete. No, why not? It is not individual points. Is it continuous? No, it is not. There are breaks in the graph. Is it a function? Does it pass our vertical line test? Again, let's check the vertical line. My vertical line there is okay. My vertical line there is okay. It does pass the vertical line test. So it can be a function even though it is neither discrete nor continuous. It does pass the vertical line test. Okay? You try. Are these functions continuous or discrete? Are they functions? The first one is continuous, but it doesn't pass the vertical line test, so it isn't a function. The second one is a continuous function. The others are discontinuous and all pass the vertical line test, so they are functions. The four here they are not only discontinuous, but they are also individual points. So those other four are also discrete. That's how we determine continuous and discrete.